Good afternoon, everybody. All right. Everyone, it's 3:30 in the afternoon. Most of you guys probably had a lot of fun last night. We know we had a few parties. Everyone, please stand up. I'm not kidding, if you can. Good afternoon, everybody. Good afternoon. That's better. I hear you, Don. You can sit down now. Great. See, we're going to have a lot of fun today. All right, so I'm John Sheehan, and I'm going to be talking about Project Centennial. And I guess remember to submit your evaluations. I was told to say that. All right, let's begin. Well, first of all, who am I? Right, so why am I up here talking to you? My name's John Sheehan. I've been on the Windows team for 5 or 6 years, I think. And I came into Windows during Windows 8 to do the Windows 8 app model, which now is we call the Universal Windows App Platform or something. Yeah, that keeps getting renamed. I can't keep up. And so I actually came into Microsoft from a company called Softricity, who Microsoft acquired. So how many people know Softricity? A few of you. We had a product called SoftGrid. How many have heard of AppV? A few more. AppV was this really cool, or is this really cool product that enterprises use to virtualize their software. And people always wondered, what did that mean? We're going to talk about those kind of things today. But yeah, so now I work in the developer platform team, doing stuff like I do the app model and some other things. But anyway, so what are we talking about today? Oh, by the way, first of all, here's a disclaimer for you. This project is still under development. First, that means that it's not in the bits that you're getting today. So all the stuff you see on stage here today, you won't be able to do in your builds. It will come in some future flight of Windows. And also, I am working with live bits that were compiled on a machine like the other day. So probably we might run into a couple of issues. If we do, just laugh and clap, and we'll get through it. So what is Project Centennial? It is a bridge from allowing you to convert your classic Windows apps to universal apps. And it's probably one of the coolest things I think we've done in a long time, because it's actually, as I'll take you through it today, you'll see it's almost magical. It is very similar to what we did with AppV, which is basically allow you to take an application that was written, like MSI, those kind of things, and actually convert it to be an AppX app. It's deployed through the store. It's done all those things. So it's very, very cool. So let's begin. So why do we do Project C? And for the rest of this thing, I'm going to call it Project C, because Centennial is just obviously way too long. First of all, there is a huge ecosystem of classic Windows apps out there. I think I heard quoted in the keynote somewhere around we know of 16 million classic Windows apps. Your Win32, your .NET apps, your WinForm apps. And we obviously knew that all of these developers wanted to be on the latest platform. They wanted to use all the latest features, and they had a huge investment in their code. But with the Universal Windows app model, there was really no great path for them. I mean, it was basically, the story was, great, rewrite your app, and you'll be fine. And that is obviously a terrible story. And so we heard the feedback. How about that? We heard the feedback. And so we started looking at, well, what would it look like to really embrace these apps and bring them forward and bring their code forward and all the cool things that they do forward. And the first thing we ran into was basically the issue that for Windows, for Win32 and .NET apps, there's no such thing as an app. There's no definition of it. This was my big rant. This is the thing that accidentally got me into Windows, for me just yelling at the Windows team, saying, you don't have an app model. Define an app, and you just can't do it. It's like, well, we have PE files like EXEs and DLLs, so we got files on disks, we have registry entries, we have MSI files, but the moment that those things get put on the system, it's just stuff. The OS doesn't understand anything about it, and the OS really can't do anything to help keep the system healthy, to update the application, to uninstall the application, nothing. And so when we did in Windows 8, when we did the Windows 8 app model, we knew that we needed to have a very clean app model, that apps could very easily be deployed, they wouldn't harm the system. Right, how many have ever installed an MSI and then your system was never right ever again? There you go, right? So that was one of the issues that we had when we started looking at, taking these classic Windows apps and bringing them forward. And really, when we talked about it, people always said, we really want them in the store. Because we got huge feedback from developers saying, I have a great app. Why can't I sell it in the store? And we had the, well, you can put a link to your website in the store. And no one was very happy with that because it means you couldn't use our payment methods, you couldn't use anything. So first, we needed an app model. And we had two options. We could create a new app model, yet another one, or we could just use the one that we already have for universal Windows apps and just bring classic Windows apps into that. And so we basically decided for the latter, obviously. And the other really cool thing about the approach that we're taking is that you can start and just do a conversion process. And your AppX, you can be in the store, you're set. And then over time, you can start to change your app. You can start to evolve it. You can start to move more things into the app container, into the universal app platform. And at a certain point, you won't have any of the classic stuff left anymore. And now you run everywhere. So it's a really cool story. We're going to talk a lot about that today. And the end result is going to be a really great user experience. Right? I mean, users for classic Windows apps are used to this: download an MSI, double click on it, get a welcome window that just says, hey, you're about to install something, hit next. Now it starts asking you questions about installing the something. You hit next again, you hit next again. Then you wait 30 minutes because it's doing something or other, God knows what. And then when you're done, hopefully your system still works. Right? That's the old experience. The new experience is the same exact experience that people get when they do UWAs, which is I can go to the store, or I can sideload if I'm sideloading, and I hit a button. I'm done. That's it. The app installs. I see progress. When the install's done, I have shortcuts and tiles, and I can launch them, and things work. And another really cool thing about it is because these are just regular apps now, you get all the same auto-update experience and everything. 3 o'clock in the morning, system wakes up, checks for updates. If they're there, it pulls them down, and they get installed and they're done. You get things like all of the great diffing stuff that we do. If you have a 2 gig package, but you've only changed a couple of files, well, first of all, any files that haven't been changed would never download because we already have them. And even the ones that have changed, if they've only somewhat changed, we still might be able to only download part of the file. And we do all that automatically. You don't have to do anything. So it's a really, really great user experience. And then the other thing is this concept of confidence. When we started Windows 8, we always talked about confidence, which is, if a user's afraid to install your app, what's the likelihood you're going to get their money? Well, it's less than it would be if they weren't afraid, right? That fear of installing something, saying, ooh, if I install something, I may have to re-image my system. Like, that fear just doesn't help anybody. And so we really want to make sure, as part of this process, that users can feel confident that they can try your app. If they like it, great. They'll give you money, they'll do whatever. And if not, they'll uninstall it, and they'll feel confident that the app has gone away and their system didn't slowly rot. And so that's really the experience that we're going for. So what does the process look like for Project C? It's pretty simple. We have this tool, or we will have this tool, because again, I said this is still under development. But you basically take your existing installer and you run it one last time. And you do it with a tool running that basically sits there in the kernel and just catches everything, bundles it up, turns it into an AppX, and you're good. All you have to do at that point is obviously just test your app, just like any other time you change something. And at that point, you're ready. You can upload it to the store. From that point forward, you should be able to just, in Visual Studio, generate those packages directly and never even have to go back to an MSI ever again. Unless you need to support Windows 7 or other releases, in which case you'll still have to keep your MSI around. But at least you should be able to have a single binary that will run on 7 installed through MSI, and then 10 installed using AppX. All right, So talking's great, but I think you'd probably rather see something. So let's start looking at an app and look at what this looks like. Great. So in the keynote, you saw that they launched Adobe Photoshop Elements 13. And we kind of did it really quickly, and so you couldn't see what was happening. But this version of Adobe Photoshop Elements, we just ran through this tool. So we took their MSI installer, we ran it through the tool, and at first, it didn't quite work. And the only thing that didn't work, and this is from all my years of experience in AppV, is always the same thing. It's licensing, right? Your app relies on the fact that your installer, as part of installation, goes and looks at the system, and it says, all right, what's the serial number of the CPU if I can get that? Let me go see what hard drive they have and what size, and basically looks around at the network card and looks at a bunch of stuff, and it takes these measurements of your system, of the user's system, packages it all up in some encrypted format, and does all this crazy stuff so that people won't steal your software. And of course, with this technique, what do? We go on one machine, we run the install, package it all up, send it to another machine, and of course the install code, the licensing code falls over and dies. And so the Adobe guys very quickly just said, great. They gave us another MSI. This one they had turned their licensing stuff off. Ran it through the tool, and this is literally the version. We ran it through the tool once, it just worked, and we were done. And so it was very, very easy. Now, that being said, as I talk about the technical details later, it's not always that easy. You may have to change your code. Your code may be doing things that don't work well with Project Centennial. There aren't a lot of them, but there are definitely some. And but luckily, if you fix those things, that code will also continue to work on Windows 7, Windows 8, Windows 8.1. So the code and the binary will continue to work the same. It's just that it might have to do something slightly different. All right, so let's look at Photoshop Elements. So we go in here, it launches. It's using the network, which is always, hey, the network's pretty fast, good job. All right, so this is Adobe Elements. And as you can see, as I said, things can go wrong and always do. And look at my taskbar is gone, which is good. As I said, this is literally a build of Windows that we took off one of our machines. But as long as Alt Tab still works, I'm fine. It'll be fine. All right, so let's first go look and see what happens. So if I go in here and look at Photoshop Elements, you'll actually see the command line that was run. And you can see it's under Program Files, Windows Apps, blah, 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 a bunch of other stuff. By the way, some of these paths are really long, and they've got a bunch of GUIDs in them and stuff. That is just an artifact of where we're at in the project. It won't finally be like that. It'll be much cleaner. We are, for the prototype, we are standing up and using AppV to help stand it up, but this is not AppV. It's actually one of the things I wanted to make abundantly clear in this talk is that while it uses a lot of the same techniques of AppV, it has a very different goal. AppV sold to enterprises. Enterprises receive MSIs. And then at that point, the enterprise was responsible for doing conversion, getting the app working, and running them. And the enterprise doesn't even have access to that code. Adobe doesn't give enterprises the bits, the C++ code for Photoshop. They give them the binaries. So they really had no opportunity to ever change any of the code. And so because of that, AppV has to do really unnatural things. The kinds of things that, hey, I know it looks like a bug, but the app's relying on the bug, and so it needs to be bug for bug compatible with anything that happens in Windows. We don't have to do that, right? So you are our target audience. You're the developer. It's your app. It's your code. If you have a bug in your code, just go fix it. I do. I fix a bug on the plane. We have bugs in our code. We go fix them. So if you have a bug in your code, please just go fix it. If you're doing something you're not supposed to, someone was asking, oh, well, I'm using the registry as a job queue, and there's different processes poking in and pulling out. And I'm like, well, actually, that would work, but please stop doing that. It's a configuration database. It's not your job queue. Use a file. That's what files are for. And so you will have to make some code changes, I guarantee it, but it won't be a lot. And again, once you make those changes, those will still continue to work on previous versions of Windows, so you'll be fine. So if we look here, we have this thing. It has been installed. The only reason I do the install, by the way, is this is a 2 gig package, and so it takes like a minute and a half or something to install, and you just don't want to sit there and watch it install, and neither did I. So, but I just installed it with the regular add APPX package command, did install, and it obviously put it under Windows apps because that's where APPX apps go. So we've got an app running with some ridiculously long path, and it's the Photoshop Elements editor. And so that's actually the version of Elements that's running. So I can shut that down now. Still no Explorer. This is a very immersive experience, the shell, so in my build. And so let's first of all, it's stuck. See that? See what I just did? Maximized it. Isn't that awesome? It's here. Yes, we did a bunch of work on the command prompt, by the way, and regardless of all this other crazy stuff that we did, we got so much positive feedback on just thank you for finally fixing the command prompt. So anyways, so if we take a quick look here, I'm in the install directory for Photoshop Elements, and you look at it, and if you've ever built a Metro Style app, Universal Windows app, any of those things, this will look very familiar. It's got a block map, because that's how we do that differential streaming of the bits down during install. It has an APPX manifest, right? It's supposed to have an APPX manifest because it's an APPX app. It has the metadata, it has the signature. I mean, it has all the stuff that is an APPX app. There's one other thing in here, too, that you're going to see that we'll talk about in a bit, but just keep an eye on that registry.dat, because that's something that's kind of interesting that most APPX apps don't have. But first, let's just take a look at the APPX manifest. By the way, I'm going really quick because I'm expecting that there's going to be a lot of questions, and so I think I'm going to try to get to as many as I can. So here's the APPX manifest, and it looks just like any other APPX manifest with a couple of differences. You'll see in there that it's referencing a Project C namespace, and you'll see that the entry point is actually the Photoshop Elements 13.0 exe. That's actually a full trust app. When we launch that, it doesn't go into an app container. It just runs as the user and runs like it normally would, except for the fact that it's basically it's running in this little environment where we show it the additional files and registry entries it expects. And you can see like it has some file type associations, stuff like that. It has a live tile, so you can see it actually has a live tile. As we talk a little bit more, you'll see that these things really are, even though they're running under Project C, they really are universal apps, and you can do just about you can do absolutely anything that you can do with a regular universal app. All right, so that's the manifest. And so if you look in here under crazy long GUID, then roots, go in here. So you'll see that there's this directory called VFS. If you look in here, there's all this stuff, right? So there's just a bunch of directories, and they have somewhat common names like System and System x86. If you go and look under System, you'll see that there's a whole bunch of DLLs there, right? The C runtime and MFC. God, they still use MFC. I feel so bad for these people. But anyways, so this is the what the installer put in the System32 directory, right? Because I don't want you to have to go change all your code so that you say, oh, well, it used to be in System32, now I have to go and figure out where it is. Like, when you're running, it'll still look like it's in System32. We'll talk about this in a bit, and we just lied to you. Sorry, virtualize, right? Right? We just lie. You say, hey, under System32, is that crazy MFC DLL there? And we're like, yep, here you go. So basically, this is how the file system stuff works, is your installer basically just vomited files all over the file system. We capture it all and package it up, and we keep it with your app. One thing this will fix, or ever heard of something called DLL hell, right? They're running with this version of MFC. Some other app gets installed that has a slightly newer version of MFC that's probably way better, and breaks your other app, and all of a sudden your app that worked yesterday doesn't work today. That's DLL hell. This prevents that from happening. All right, so let's go back. Let's go back down a couple directories. Crazy good, crazy good. All right, so let's go in here. You can look quickly. There's basically, the other thing that's in here is things like assets and stuff. Some very cool things is the moment that you do the conversion, you now have a live tile. And it's a real live tile. You can update your live tile. You can do everything you would normally do with the live tile. You can start using WNS immediately, all those kind of things. But there's this one other thing that's sitting in here, which is this registry.dat file. Let's go. Oh, okay. All right, my immersive experience will not let me do start R, so let's have to do it this way. So let's do regedit. And let's actually go and take a look and see what that thing is. So if I go and load, so first of all, that registry.dat file is actually a hive. It's right here. And so if I open that guy, let's give it a name, we'll call it PSE. And this is actually the hive file that the converter created. And so what it is basically just like your installer like threw all those files on disk, it also threw a ton of stuff in the registry. And we don't want that stuff there. Does anyone know why when you install lots and lots and lots of apps, like your system gets slower, it like boots slower? It's because all that stuff that you guys throw into the registry, because we told you to, by the way, so it is 100% our fault. We told you to put it there, and a ton of our features like COM require it to be there unless you do, reg-free COM, which no one does. And so we told you to put it there, so you did exactly what we told you. You put it there, but what happens is that registry file grows and grows and grows. And then every time we boot the system, we have to load the whole thing. And then you also put stuff in HKCU, and that grows. And every time a user logs in, we have to load that. And so that's why over time you're like, God, when I first got this machine, it booted really quick. That was one of its selling points. And now a year later, or a year and a half later, it boots, it's like 10 seconds slower to boot. Why is that? It's just because more and more stuff's getting piled into the system and loaded. And so we don't want that. And I don't think users do either. And so anyways, when the installer ran, let's just go in and look at something. Oh, there's one. That's an interesting one, organizer. So you go look in the registry. The installer laid all this stuff down. Now, I have no idea what this is. Obviously, only the Adobe engineers know what this stuff is. But they obviously must really, really rely on max undoable operations and min page file mem MB. Right? So those things are really important to that app. But they're really not important to boot the system. So we take all that stuff and we put it into this reg file. And in a little bit, I'll talk about how it all actually comes together at the end. But so far, this is basically what the installer did to your system. Funnily enough, when AppV first got bought by Microsoft, I got a call very quickly from the SQL Server team. Okay, server stuff, we're client stuff, NT service thingy, we're apps. And they said, oh, can we use the sequencer, which is the tool that AppV has? I said, yeah, why? They said, we have no idea what our installer does to the system. We want to figure it out. I said, really? They said, yeah. So next time I was in Redmond, I went in there, we sequenced it, and they were like just spellbound for hours going through. It's just stuff that accumulated over the years. Some engineer built some feature 15 years ago and then updated the MSI to throw more stuff in there, and that code has been sitting there forever. And the big problem that they had, by the way, was that sometimes SQL Server just kind of stopped working. And it turned out it was like installation issues, of course, because somehow or other the install didn't work right because MSI is just terrible. By the way, I own MSI, so I'm allowed to say that. Like it's. You're not allowed to say that about my product, but I totally can. All right, so that's basically what it looks like. That's the real running code as of like a couple of days ago. It will get better. So let's go back to the deck. So what was going on there? Well, what we did was we took this MSI, right, and we run it through this tool, which we're calling the converter, because we're really good with names. What that does is literally it monitors everything that your installer does to the system. All the awful, terrible things that it does to the system, it sits there and catches all of them. It's basically a bunch of kernel filter drivers. Sits there and it captures everything. And then it turns around and it creates an AppX. But as part of creating the AppX, it actually needs to figure out what all that junk was, because some of that stuff's important, like COM. Right? The fact that a bunch of registry keys and DLLs all thrown down on the system, that's a COM object. And we need to figure that stuff out because later when we deploy the application, we want to be able to tell COM that there's a COM object there. What we don't want to do is just have to say, hey, COM, there's a whole bunch of registry stuff over here too, so now start looking in more places to try to find all the COM stuff. We want to be able to tell COM, listen, hey, I'm installing an app, here's some COM objects, and now you can know about them. And we're actually, hopefully we'll be able to do it without putting anything else in the registry so that the registry stays really small. So once they basically do all the analysis and package it, figure it all out, then we spit it out into an AppX file. And so basically, the AppX file is going to have a very specific format for Project Centennial. There's going to be that reg.dat file that basically will hold all your registry stuff. There'll be a separate folder that contains all of the things that we need to lie to you about, right? So all those files that your installer, tried to put in System32, like we're just going to have a very simple format where we say if a file is in a directory called System, we know that's the System32 directory. So for some of you might not even want to use the converter, honestly. You might want to say, you know what? I have an MSI, or I know what my installer is supposed to do. And if you do, you can skip it. You can just basically, create the AppX format yourself and just do it using regular tools and not even go through the converter. But the converter is actually pretty convenient, and as SQL Server team taught us, most of you don't even know what your installers actually do to our systems. So then the next thing you're going to need to do, as I talked before, is really you're going to need to test and update. Now, the Project Centennial, we really want to embrace your apps, but not everything that your app does, right? I have this talk I give, which is called Win32, the good parts. Insinuating there's also Win32, the not so good parts. Win32, the good parts, are things that apps do, right? Things that you do where you're running as the user, you're not running in the kernel. Like that's supposed to be for driver stuff. That's supposed to be for hardware stuff. You're not running as an NT service. That's supposed to be for system stuff, right? We really got it all mixed up with Win32 in that we kind of just let you do anything, whether not saying, hey, these kind of things are good things to do, these kind of things, not so much. Maybe if you're an antivirus vendor, you should be doing that, because that's like system software. We're really targeting the apps, the stuff that users interact with and get value out of. And so I've already talked privately to some companies, and they sort of said, okay, well, I understand, but why? And here's the number one reason is, you remember that little spiel at the beginning about a great user experience? I just want to hit install and have it work. What if I'm not an admin? Is it smart to say, hey, I'm not an admin, I hit a button, and now because I hit that button, there's code running as the system? Probably not, right? If you're in an enterprise, I can tell you your IT group will say definitely not. And had we done that, the very first thing we would have had to do would have been add a group policy to turn that off, right? And so rather than do that, we said, hey, we want users to feel confident that this software is not going to destroy their systems. So you only get to run as the user. If you like your code running elevated as admin, like UAC prompt style, nope. So if your software is doing stuff like that, that's going to be the real change that you're going to have to deal with. Luckily, when we talk to a lot of people, we find out, why do you even have an NT service? Its code's running all the time. It runs as local system. Why are you doing that? The number one reason, can anyone guess? Auto updaters, exactly, right? Because I need to check every night to figure out if there's new software and download it and tell the user and tell them to install it and everything. Well, guess what? We don't need your stupid auto updaters anymore. We have one. So just take that code and throw it away, right? And let us deal with that mundane stuff. All right. So, and then when you're done, you get to make money, right? You get to go up to the store, you get to get lots of users, and you get to sell your software. So I want to talk one more thing about AppV at this stage, because this diagram is basically verbatim if I was up here giving an AppV talk. And so people have been asking about, well, there's AppV, and now you're going to have this Project Centennial thing. I already explained that they're very different. But one thing that the AppV team is going to do is if you convert to Project Centennial, they will make sure that they can run, deploy, manage your software. And potentially even on Windows 7. Now, you guys are developers. You probably don't realize this. But the IT groups and the enterprises that you sell your software to, they absolutely hate your installers. They hate them so much, like they lay awake at night thinking about them. And a lot of them spend a lot of money to convert to AppV. And if you can offer them packages that they don't have to take your installers and resequence them and reconvert them, they're going to be really excited. You will have some really, really happy customers. And so the AppV team has committed to go off and do this work. And honestly, it's really not that much work, because these two things are very similar. But they're going to do that work. And so if you end up having a Project C package, you are going to be AppV ready. So I want to talk a little bit about lying. Sorry, virtualization. Most people ask, how does how does all this stuff work? What do I get to change? What do I see? And it's actually pretty simple. We do a bunch of registry and file system merging, and we do some redirection. And so basically, this is kind of what namespace merging looks like. Your app actually sees a merged view of the world. It sees everything on the local system. So if there are plugins installed that you can load, like you'll see all those. You'll see all the stuff that's normally on the system. But then what we'll also do is we'll take that, like those C runtime or whatever, all those files, and we merge them in, and we create this merged view. So as far as your app's concerned, the installer went off and made all kinds of changes to the system, because it looks exactly as if that had happened. But it really didn't. One nice thing about this is, first of all, we don't muddy up the system and end up with DLL hell. But the other one is we can actually uninstall. How many of you guys realize that it's actually impossible to build a safe uninstaller? Like, there is no way to do it, because the previous non-app model will say it didn't actually, there was no way to know whether removing a file was safe or not. And you say, well, but I put the files down. Of course I can take them away. Unless someone else would have also laid down the same file, and they said, oh, look, it's already there. Great, I don't have to put that file down. And then you take it away, and that app breaks. Right? And so that was one of the things, there was one of the financial companies in New York. They had this policy. They would never, ever, ever uninstall an app. They had something they called hubbling. So they wouldn't run your uninstaller, but if they needed to get rid of an app, they would hubble it. I'm like, what does that mean? And they were like, basically, we render all the EXEs as unrunnable and just leave it there. I'm like, are you serious? They said, we had too many times we tried to uninstall something, took down our systems, and we lost money, so we don't do that anymore. With AppX and with the app model, we can actually safely uninstall stuff. Because what we don't allow people to do is just randomly take dependencies on files in your app. And one of the things we actually do is, if you saw that big, long path, the path to your app changes constantly. Every time you release a new version, the path changes. We do that for a whole bunch of reasons internally, because it turns out when you're installing, never, ever, 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 ever edit a file. If you ever edit a file, we figured out, sometimes power goes out. Like, it does happen. Sometimes you lose data. And if the power goes out while you're in the middle of editing a file, the user system is now in some crazy state, and they have to flatten the machine. And so we never do that. And so because of this, even if someone was really tempted to try and go and take some crazy dependency on your files, first of all, there would no be stable path for them to do. And then one other thing we're actually doing is we are going to change the loader so that if someone that's not you tries to load your files into their process, it'll fail. The reason that we have to do this is we want installs to be reliable, to not be terrible like they are now. And so, and it turns out that if your app starts getting loaded into lots of other processes, well, guess what? Now it's really hard to service you because someone's loaded your DLL, we go and install the new version. Maybe they're trying to use it to talk to you for some reason. You've changed some COM interface. Everything blows up. The user gets angry. So we just don't let it happen. And so, so this is the wonderful lies that we tell you or tell your code is this nice merging. The next thing that we do is what happens when, there we go. What happens when you write something to the system? Well, first of all, if you're writing to the registry, we redirect it. You say, I'm going to write to HKCU, blah, 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 blah. And we say, yep, you totally did. Good job. We write it over here. So that way, when we go to uninstall you, we can just rip it out, and we don't have to worry about the fact that, like, hey, I wonder if other people are taking dependencies on that crazy thing that you put into the registry. Which does mean if you went and wrote software that tried to use the registry to talk to some other piece of software from some other company, we just broke you. And I'm so happy that we broke you because it was terrible. When it comes to the file system, basically the only thing that we redirect is app data. Right? The app data folder is just that. It's your app data. Users aren't supposed to go in poking around there looking at stuff. We hide it. We mark it all kinds of ways so that users don't see it. That's like your personal little scratch space. Well, we just redirect that. So if your app's like, hey, C:\users, blah, 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 app data. Yep, your code looks like it wrote it there. We just redirect it somewhere else. And one really nice side effect about that is in a few minutes I'm going to talk about building new features. We put it in the same app data directory where all other universal apps get their app data put. And so it actually starts future-proofing. It starts like automatically moving your code forward to use the right model without you even doing anything. At the same time, if you don't like being lied to, you can just write there directly. Like, you don't have to let us lie to you. You can actually just go do the right thing. So that's how that works. A little bit about full trust activations. How many people actually even heard the term app container? Like a few of you. When you build a universal app, it runs in an app container. It's basically a sandbox. And we lock your code away, and then we give you access to the system to things that the user would want your app to access. And we don't just give you carte blanche to do whatever you want. And this has been a huge success for us because those apps that people get from the store, no one ever thinks twice. I hit install. Hey, that app's great. I'll use it. It's not so great. I'll uninstall it. It's because it really can't do any damage. These apps, we're going to run full trust. And full trust is outside of the app container. Full trust means you're running as the actual user. And so because of this, like, please be careful. Right? It's a lot of people think, well, hey, it's great. I get to do everything. And it's like the really bad part about it is you can do everything. Ever have a bug? Anyone ever write a bug before? Ever have a bug in your code? Yeah. You have a bug and someone exploits it, you just totally pwned the user. Like, I don't know about you, but I actually don't want that. Like, that's great power, yay, but I don't want I don't want that responsibility. I have my app, I have the data that I access, that's all I really want to have access to. Well, that's not the way the non-app model worked. And so we're going to continue to run your stuff full trust so that it can work. But we hope, and we will help you over time, start migrating your code to the app container so that you can eventually protect the user and have a much more secure model. So the things that in V1 that we're targeting right now, like I tap on the tile, your app, kind of like I did with Photoshop Elements, your app launches. That's all. It's running full trust. You're happy. You register for file type associations or custom URI schemes or something. Great. we'll run that code full trust. Other than that, if you want to do other things, like, for example, I had someone say, hey, can I build one of those, I saw in the keynote that app-to-app contract thing where apps can call into me and I can provide data back and the banned stuff. And the answer is, yeah, you can. And when you write that code, you're going to write universal Windows app code that runs in the app container. And so, but at the same time, the big question is, okay, but what if the thing I'm doing actually it's my older Win32 or .NET code? And the answer is, we're going to let you activate you're going to have some code in that scenario running in the app container. You're going to have some running full trust. We'll give you a communication pipe to talk to each other, and we'll let you activate each other. So if someone calls your app-to-app contract and your full trust code isn't running yet, we'll give you the ability to launch it. If your full trust code's running and you want to call down into your app container code, we'll let you do that. We'll give you an efficient communication channel for that. And the reason that we're doing this is because overall, we think most people actually, and the feedback we've gotten is most people actually want to be a real universal Windows app that'll run anywhere. Right? Like, how many of you guys, wouldn't it be cool to run on Xbox, run in HoloLens, run in all these cool new devices? As long as you have that full trust code, you won't run on those devices because those devices only use the pure universal Windows app model. They will only run an app container. They only call those sets of APIs that are supported for that. And so, but most people actually want to get to, like, it's a historical artifact that their code is the way it is. You wrote the code that we told you to write to do what you wanted to do. And so, we know that people want to get there. And so the very first thing that we did was say, hey, the moment that you run that conversion process, you're a universal Windows app, which means you can do anything that a universal Windows app does. Seriously, anything. Because why not? You are a universal Windows app. You want to basically add an app-to-app contract? Go and add app-to-app contract. You want to be a picker target, you want to be a share target, whatever the stuff you want to do, you can do that. And so I'm going to try to get to the question soon. And so basically, the process that you'll go through if you actually really want to get to a universal Windows app. If you don't, by the way, that's fine. You can keep running with Project C. But we internally have been doing this, and we've got a lot of experience with it. So for example, I don't know if you guys have been playing with the Windows Insider builds, but if you have, you'll notice at the start menu, like parts of the shell, the Action Center, all those things, those are actually UWAs. They run in an app container. And how did we get there? Well, we started with, we had full trust code that was like, not MFC, but our internal equivalent of MFC. Totally awesome. And the very first thing that everyone does is they do XAML and they put their UI in there, right? And so they basically, so all these teams, they said, great, we want a new, really modern feeling UI, so they go and build it. And they look at all the stuff that they can do in the app container, they just continue to pull that stuff in. And at first, not everything can work, just because a bunch of it's old code that did other stuff. And so they leave that code full trust, and they basically talk to it. They have a little pipe to it. And so, and then over time, more and more of those things, they keep moving into their app over time. Luckily, the cool thing is the app works the whole time, right? So you have a working app. You slowly make changes at whatever pace is right for your business. And then at a certain point, you don't have any more full trust code left. You're done. And once you're done there, now you can go everywhere. You can run on HoloLens, you can run on Xbox, you can run on phone, you can run anywhere you want. And that is that's our main goal for this project. Yes, you want your apps in the store, we want your apps in the store, but we really want your code bases to live on for a long time. Other things that we're doing is, back in Win8, we had this rule where we basically, not rule, but it was like a guideline where we said, okay, we're going to build all these new great APIs that are much easier to use. The Win32, like, call us with a null pointer and we'll fail and then we'll tell you the size. Like, most people hated those patterns, and so we gave them all new APIs. But we did this thing where we said, well, if we have a new one, then we won't bring the old one forward into the development platform for universal apps. And so there were things like, hey, I have tons of WinSock code. And we said, see, we have WinRT sockets. They're much easier to use. Use those. And you're like, well, but I already have code. And it's really easy because it already works and it's already been debugged. So I think using that's easier. And so one change that we've made in Windows 10 is we're bringing a ton of those things back. So things like WinSock, create thread, all those things. Like, yes, we have an awesome thread pool, but if you already have create thread code, just go use that code. And those things will be available inside the app container, inside MSDK. That will just pass the regular whack. And so actually moving all that code into app container gets much, much, much easier. The big things that you'll do are things like, well, I used to use that old like file open picker. Well, change the code to use the new one. The new one has a ton more features that the old one doesn't support, like picking from other apps and stuff. You make a few changes like that, and in our experience it's actually been quite easy to make the move. Much easier than we thought. I really should have bet people because I was trying to say it was going to be easy, and everyone told me it was going to be hard. I was right, they were wrong. All right, so we should get to the questions. Like, here's the summary, right? So Project C is your bridge from CWAs to UWAs. Got that right? Good. And we'll convert you to an AppX. We'll lie to you, and you can start using the UWA features. So 15 minutes, perfect. Questions? Sorry, so there's mics here. It'd be more convenient to get to the mics because then I have to do less work by not repeating your question. I'm lazy, as all good developers are.
So this is cool, and I work in the industrial space.
Yep.
And most of our customers don't have access to the Windows Store, so can we convert it to XApp code and still just install it without using
absolutely.
the Windows Store?
Yeah, there's like getting into the store is nice, and if you don't want to, then don't. But yes, you still use this. This is just part of the platform. Like that app that I did, I just did add AppX package. So the rules for Project C apps are the same as for all the other apps, right? And I don't know if you've seen in some of the other demos and stuff where now we have a page. If you want to sideload apps, you flip a switch. That switch affects Project C exactly the same way as it does for all other AppX. All right, we'll go side to side. So
how does this work between single user or multi-user apps? I mean, obviously certain apps are big and there's multiple users on a system.
Well, so it works the same way that it does for other AppX apps, which is, the installation is per user, meaning that like if you and I are both running on the same machine and you install an app, I don't see it unless I also install it. Under the covers, there's still only one copy of the app. We have a single instance store and everything. And when your app gets run, it runs as that user. If you're on a terminal server and there's 100 users and they all launch the app, there's 100 instances of the app, one running in each session.
When it's writing the data to the user directory, then is that then roamed like a normal, like a universal app on OneDrive and all that, so it goes from machine to machine?
Well, so what we did is because the non-app model world didn't actually do roaming, we had that roaming directory at app data. I'm going to, by the way, after this talk, I'm also going to be doing an hour-and-a-half thing out in the expert section or whatever it's called. What's it called? Insider Lounge. I'm going to be in the Insider Lounge after this, and we can have a longer talk about like what was wrong with that. But all that stuff we put in the non-roaming section. But your app has a roaming directory as well, and you can call those APIs, and you can start, the moment you do the conversion, you start running, you can start put stuff in the roaming directory, and you will roam.
So just to clarify that the registry stuff, the HKey, current user stuff, will that automatically roam then?
No.
Okay, it won't roam.
No, it won't, because actually most apps can't handle that anyway.
So our app does things like automatically set up Samba shares or...
Sorry, can you speak out?
Sorry. I said our app does things like automatically setting up Samba shares or connecting to certain wireless networks automatically. Is that going to be stuff we could do with this? And if not, is there a way I could easily suppress it in the app so those kinds of things don't show up?
Well, at runtime, your app can do whatever it would normally do,
okay,
unless it was doing it by going through a UAC prompt to run admin. Mm-hmm. So yeah, you can still do all the same stuff that you would normally do. The biggest thing is if what you were doing was going and editing the registry to change the way the OS works, nope. But other than that, yeah.
And if we do UAC things, what does that look like if we try to do that?
It'll fail.
Okay.
Yeah, we're just gonna block it.
Okay.
Because users like the whole promise of this is you're not gonna regret it. The moment you start going rogue and running a system and then doing fun stuff, you'll have the best of intentions, but you might mess up their machine.
Okay, great, thanks.
Okay, so what about things that were previously disallowed from store apps? For example, accessing custom hardware using IOCL calls, or doing IPC, like using named pipes or things like that. Will that still work?
Yeah, that'll all continue to work because your app is still just running. I mean, really mostly what we did was just change the underlying installation, deployment, and management stuff. So your code's still running. You can continue to do whatever you did before.
So I can use COM and WMI and all those things as well?
Yes, COM and WMI, all that stuff will work. But the big like no-no is where like if you did something that caused some like other app to load your binaries into that app or something, like we're blocking that for now. We do, by the way, we do believe deeply in extensibility. We believe deeply in plugins and all those things. And we're currently working on, we're not announcing all the details now, but we are working on a model to have a nice, clean plugin model. But that probably won't be part of E1. But yeah, other than that, it's just your code. It's just going to run.
And how does the desktop activity moderator, how does that affect this?
I'm sorry, could you say
DAM, the desktop activity moderator, when going into connected standby,
yeah.
How does that affect these type of applications?
The same as if you'd installed them with MSI.
So, but you said that there are apps, like there's a portion of the app that can do the same thing as
Windows. Yeah. Any of the stuff that you do that's like, so let's just take, for example, you say, hey.
Background triggers,
I want to do background triggers and stuff. Those all will work. Like, guys, remember the everything seriously thing? True. Yes, you can do all those things. That code will run in the app container, and that code will be subject to PLM, as always. But yes, you can do all those things.
And it can call into the code that's suspended by the desktop activity moderator.
Well, actually, the way that DAM works is when we wake up the system, we actually do wake those processes for a brief period of time. So yes, it actually will work. The original design of it, we didn't, and it turned out that not everything worked out so great, so we had to change it.
So our app uses something called code meter that's meant to basically encrypt the binaries and keep them tamper resistant to prevent a Stuxnet type of attack. Does this provide some of that same type of functionality?
Oh yeah, the same way. So what we do for all of the binaries that get deployed through AppX is, first of all, as they come down, we have like everything's digitally signed. We have all the checksums. As every block comes off the network, we check if it's been tampered. We throw it away. Once it gets on disk, we lock it down with a whole bunch of different things. We have some, secret stuff that we do, that we change the kernel and the file system. We have a thing called a superackle, like, so you can't just go and, hey, I'm just going to take privilege and just take over and do stuff. All of that also applies. One other cool thing that you can do, at any moment, your code, we have an API that can call and say, tell me if that file has been tampered with. Go recheck it right now and tell me if it still passes the digital signature check. And so, yes, so you get all of that for free as part of the conversion.
Okay, and second, so will Visual Studio 2015, the full version, use this AppX, or?
Funnily enough, it was supported in AppV for years. Like, we had lots of customers doing it, and we talked to that group many times, and we had never done it. And then they saw the keynote, and I immediately got an email. So, don't know, but at least I can tell you people are interested now.
If my app uses Clickonce to install, what would be the process to bring it forward?
You would still go and run it through the converter. You would do the Clickonce thing, whatever. But I can tell you right now, I know we've tried it. We've tried that in the past, and we had it working, but we haven't tested that with Project C yet. But yeah, you would basically go through the same process. But from that point forward, you wouldn't be a Clickonce app anymore, right? All the servicing would now just come through the AppX deployment stack.
Thank you.
I was going to ask about Clickonce as well. What about some cool features of Clickonce, like optional download groups and stuff? Will be the support for these kind of things in AppX?
You say optional member groups?
Optional download groups.
Oh, optional download groups?
Yeah.
No, so we're not doing anything, like we're not taking any of the Clickonce technology, but at the same time, we are doing things like we're working on, and it's not there yet, but we already know we've gotten lots of requests just even for universal apps to say, I want to have downloadable content where, and we know how to do it because if you actually look at AppX, we actually have this thing called an AppX bundle. It's made up of a bunch of AppX files. And we already do things like automatically do language packs and everything. So we are planning on extending it to that, but we will not be doing it the way that Clickonce's doing it. We'd be doing it the AppX way.
What about merge modules, where we have a shared merge module between two different applications that gets installed in its own directory right now?
Yeah, so, well, first of all, two things. Merge modules are evil. But what we do is way better, which is under the covers, when I talked about that like diffing, we don't just diff between two versions of your app, we diff across everything. So if you have 10 different like apps that all have the same DLL, like for example, SQLite's really popular, right? And SQLite ships a version that supports universal apps. You have 100 apps that are all using SQLite, there's one copy on disk, there's one DLL on disk. And you get all the same benefits that you get had you actually used a merge module and try to stuff the same things into the same actual directory.
So when we do the conversion, do we just let the merge module install and then it'll just figure it out, and then when we install the other app, it'll just know it's there? And
yep, exactly. Yeah, you do nothing. You just run the conversion twice, let those evil merge modules do whatever stuff that they did. Don't worry about it, and the deployment stack takes care of everything automatically.
So it sounds like Project C protects against accidental, problems with the system. Is it also a security?
No, no.
So will there then be store apps that you now can't really necessarily trust apps from the store if they're Project C apps because they're full trust?
Yeah. So this is one of the things we talked about. And by the way, I don't work on the store. I don't know what store policies are going to be in place. I don't know what the onboarding is going to look like or whatever. But yeah, we definitely know that is absolutely a concern. And we've been balancing the two. Like early on, we erred on the side of we're not going to do it because it might potentially. But we also trust you guys, and so we're going to put some trust in you. Yeah, sort of. But there will be checks and balances. I mean, luckily, because it's coming through the AppX stack, if we have to, we still have like kill-bit mechanisms and stuff like that. So if something malicious does make it into the store and does start harming our users, we can turn it off. I hope that doesn't happen often.
Yeah, and so that would include like if I process.start something and it would perhaps go around the redirection stuff that you're working on.
Absolutely.
Okay.
I mean, if you're evil, then you'll be able to get around this stuff.
I'm not evil, by the way.
You're not personally evil. But yeah, it's one of those things that if we find people coloring outside the lines, like we have the rails there, so for people who mean well, like we help them do the right thing without even changing your code, which I think is pretty neat. Other than that, like we're just gonna have to keep an eye out. But we always have anytime you deploy software, even in the browser, like there's always that problem, and so all the other mitigations that we have for this stuff we'll continue to use.
So I'm still trying to get my head around this full trust and app container stuff.
Okay.
How does native code call into the universal Windows platform? Do you still use C++ CX, or is this some sort of replacement for that?
I'm not sure I understand the question. Let me try to explain as quickly as I can. So you have your full trust code running, right? And you can activate the code in the app container either through some background task, or we will give you a call to just say, hey, run my code.
Okay.
So you'll have that. And then what we'll just give you is we will give you a pipe to communicate. Now your question might be, what does the pipe look like? And is it COM? Like, is it DCOM? Is it this? Is it that? We're still sussing that out. We've done a couple. We've been playing with it, and we've been doing a few different ones. It turns out that DCOM can be somewhat tricky, we'll say. especially if you have two processes, one of which can be suspended and one of which isn't going to be suspended. And so we currently have been thinking about actually using the app-to-app model that we have to go between apps right now, where you basically pass value sets, which is kind of like more, it's basically a glorified JSON document, and just passing that back and forth. And so we've played around with that some, and it's actually quite promising. And so my guess is it'll probably look something like that. I think I have time for one more question.
Okay. I'm going to apologize for the bad word, but ActiveX, it's COM. And in the past, we had an option to put on manifest the registry, so I don't need to, actually, I can run like a portable application.
Mm-hmm.
That
Yeah, Registry
will be supported.
Yeah.
Yeah.
So, so right now,
there will be two manifests, right? And that manifest could even go to the resources of the executable. So it's kind of tricky. I don't know how this process will be able to get it.
Well, so right now, so the ActiveX was a bunch of different things. One of it was like a deployment technology. Not doing that, right? So you're not going to do that. But if you had an ActiveX control and you were using it in your app, that'll continue to work whether you were using Registry COM or you were using regular COM. Those will both work, and so I think you'll be fine. But if you're talking about that other part, which is the deployment part, no. Like you wouldn't be able to say, hey, I'm going to take the ActiveX control, I'm going to put it up on a website and just have it automatically update itself. That wouldn't work. All right, I think, is that time?
One more?
Come on,
All right,
one more.
so, but if you still have questions, we're just going over to the, what's it called? Insider Lounge around the corner for another hour and a half. Thanks.